You know, when we look up at the night sky and ask that age-old question, are we alone? Finding the answer isn't just for science fiction anymore. Today, we're going to take a journey to see how scientists are actually looking for life, and not just on some far-flung exoplanet, but right here in our own cosmic neighborhood. So let's kick things off not light years away, but with the incredible worlds right next door.
I love that quote because it just hits the nail on the head, right? The moons zipping around the giants of our solar system, they aren't just dead rocks. They are really complex, dynamic worlds, and each one has its own amazing story to tell.
All right, so let's start our tour with some of the most bizarre, beautiful, and maybe, just maybe, life-bearing worlds orbiting our planetary neighbors.
First up, we've got Mimas. Yeah, it's famously called the Death Star moon, and you can see why. That massive crater makes it look like it's been through a serious cosmic beatdown. For years, scientists just figured it was a geologically dead chunk of ice. But now, get this, recent studies are hinting at something absolutely incredible, a potential ocean, hidden deep beneath that battered, icy crust.
Okay, so if Mimas is hinting at an ocean, Saturn's other moon, Enceladus, is basically shouting about it from the rooftops. The Cassini spacecraft actually saw these gigantic geysers of water vapor, ice, and even organic molecules erupting from cracks near its south pole. I mean, these plumes are direct evidence of a huge saltwater ocean down below, which makes Enceladus one of the most exciting places to look for life, period.
And then there's Titan. This moon is bigger than the planet Mercury. It's the only other place in the entire solar system where we found stable liquid on the surface. But here's the twist. It's not water. Titan has rivers, lakes, and even seas of liquid methane and ethane, all hiding under this thick, golden, nitrogen-rich haze. It's totally alien, but at the same time, it's eerily familiar.
So you see all of this, oceans of water, seas of methane, complex chemistry happening, and it all leads to the ultimate question, doesn't it? Could any of these strange, beautiful, distant worlds actually be home to life? Well, to even begin to answer that, we first have to completely rethink what life really needs to get by.
And you know what's wild? The key to unlocking that possibility isn't millions of miles away in space. It's right here, in the darkest, most extreme corners of our own planet. It turns out, our definition of a habitable world has been way, way too narrow.
For most of human history, we just assumed all life depended on the sun, photosynthesis. But now we know about something called chemosynthesis. This is a process where organisms don't need a single ray of sunlight. Instead, they get their energy from chemical reactions, basically munching on things like methane and hydrogen sulfide. This completely changes the game, rewriting the rules of where life can exist.
And you can see just how powerful this is in the deepest trenches of our own oceans. We're talking nearly 6 miles down, in complete total darkness, under crushing pressure. And scientists recently found these massive, thriving ecosystems, entire communities of tube worms and mollusks. It's living proof that complex life can flourish without any sunlight at all.
But wait, it gets even more surprising. We've also figured out that Earth's water isn't just sitting on the surface. We've found evidence of a massive reservoir of water, wait for it, 400 miles deep inside the planet's mantle.
Now, don't picture some giant underground lake you could sail a boat on. It's way cooler than that. This water is actually chemically trapped inside the molecular structure of this blue crystal called ringwoodite. So you can think of it like a giant water-soaked sponge deep, deep within the Earth.
And the scale of this is it's staggering. This hidden reservoir could hold up to 3 times more water than all of our surface oceans combined. So what this really tells us is that our own planet has shown us the ingredients for life can exist in places we never, ever thought to look before.
Okay, so with this new, much broader understanding of where life could be hiding, how do we actually go out and look for it? What are the specific clues that scientists are hunting for across the cosmos?
Well, the search pretty much breaks down into 2 main categories. On one side, you have biosignatures. This is evidence of biology itself. Could be anything from a fossilized microbe to a weird mix of gases in an atmosphere that just screams life. Then, on the other side, you've got technosignatures. This is the search for signs of advanced technology, things like radio signals, or maybe even industrial pollution.
But this search comes with a huge challenge, the false positive. See, nature is really clever, and a lot of non-living, just plain old geological or chemical processes can create things that look a lot like a sign of life. For example, a planet could have an oxygen-rich atmosphere, and you might think, Jackpot, photosynthesis. But nope, it could just be that intense starlight is breaking down carbon dioxide molecules. That's why scientists always need multiple lines of evidence before they'll even think about making a claim.
So, to get that evidence and avoid those false alarms, we are developing an incredible new generation of tools designed specifically for this cosmic detective work.
For instance, check this out. This little device might not look like much, but it's a portable USB-powered DNA sequencer called the Minion, and it's already been tested, successfully, on the International Space Station. This is the kind of tech we could one day send to Mars or Europa to search for life as we know it, right down at the molecular level.
And the number of places to even use these tools is just exploding. I mean, thanks to missions like the Kepler Space Telescope, we've gone from knowing about a handful of planets outside our solar system to confirming thousands of them. This chart just gives you a sense of that scale. Every single dot is a new world. Our map of potential places to investigate has become unbelievably vast.
But sifting through all of that data is a monumental task. That's where AI is becoming a total game changer. We are now using powerful machine learning algorithms to chew through these huge, complex data sets. They help us spot the faint signals and the subtle patterns of a potentially living world that a human eye might just completely miss.
So, what's next? Where do we go from here? Well, the coming decades are shaping up to be a golden age for astrobiology, with a whole new fleet of missions already on the drawing board.
We've got heavy hitters like the James Webb Space Telescope scanning the atmospheres of distant exoplanets for those telltale biosignatures. Closer to home, we've got dedicated missions like the Europa Clipper, which is going to get an amazing up-close look at Jupiter's icy moon. And we're also going to see more nimble exploration, using fleets of small, innovative spacecraft that let us take more risks and visit more worlds more often.
Which really brings us right back to where we started. These moons, these planets, these faraway worlds, they aren't just objects floating in space. They're ancient storytellers, holding the history of our solar system and, maybe, just maybe, the secrets to life itself. The search really is just beginning. We are finally building the tools to actually read those ancient stories. So the biggest question of all remains, what incredible secrets are they waiting to tell us?